Hello students, it is the fifth day of first lesson gravitation from science part first. So far we have discussed acceleration due to gravity within the last period, value of g, that is 9.8, that is the mean value on the surface of earth, but value of g varies according to 3 point of view. Number 1, the location on the surface of earth, highest at the pole, lowest at the equator, and the mean is 9.8. It changes 4 times while covering the distance along the surface of earth. That also we have discussed. Second, according to height, as height increases, acceleration due to gravity goes on decreasing and it becomes zero at one location. Thirdly, we have discussed as per the depth. As depth increases, that means we are reaching towards the center of earth, and at the center of earth acceleration due to gravity is zero. That means highest to zero, that means it decreases. So from surface it is the highest. Height increases, value of g decreases. If depth increases, that also decreases. That we have discussed. And again, acceleration due to gravity of earth, acceleration due to gravity of moon is different because all the planets have different masses and different radius. And so as per the planet, value of g goes on changing, and we are using this content to explain today's facts. Which are these? See, we are discussing now mass and the weight. First of all, we should discuss what is mass, then what is weight, and the third question we are discussing, what is difference in between mass and weight. So starts with the mass. In the 9th standard, measuring the matter, that was the 4th lesson we have discussed. Within that lesson, the mass concept we have discussed elaborately. So what is mass? Mass is the amount of matter present in object. Suppose we having laddus. Which laddus? Motichur ke laddus. So what are within that one? Motis, that is the kada. Then if one smaller particle having the mass of 1 gram and the laddu is made up of 1000 such small particles, so each particle's weight is 1 gram, that is mass is 1 gram, and it is made up of 1000 particles. So definitely how many particles are there? 1000. So what is the total mass of that laddu? That is 1000. What may be the unit? So like this one, how many particles are present in that object and what is the mass of one particle? In ratio of that we are calculating this. But how to define mass? Mass is the amount of matter present in the object. See, we are going to discuss what is the mass of water, that is the one molecule of water. Molecular mass of water means H2O. This water is made up of 2 atoms of hydrogen and 1 atom of oxygen. So we are representing as H2O. So what is the mass of atomic mass of hydrogen? Because only one subatomic particle is there. So atomic mass of this hydrogen is 1 Dalton. Then how many subparticles are present in atom of oxygen? There are 16. That means 8 proton and 8 neutron. And so molecular mass of one oxygen is, atomic mass of one oxygen is 16 Dalton. So water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Combine this, then molecule of water is going to form. So how to find the mass of one molecule of water? See, hydrogen atomic mass is 1. Such 2 particles are there. So 2 into 1, total mass is 2 Dalton. Oxygen, within that one only 1. So 1 Oxygen's atomic mass is 16. Such only one particle is there. 16 ones are 16. So totally we are getting 18 Dalton. So mass of one molecule of water is 18 Dalton. So like this one, a container or object contain how many particles or how many molecules according to that one mass get depend. So that is the total of the mass. What is the SI unit of mass? Kilogram. See, suppose I am taking one object and the mass of one object is 1 kg. Then wherever you go, you will go in Pakistan, China, America, on the moon, on the mass will not change because number of particles exist in that object remain same everywhere. At the center of Earth also the particles remain same, particles will not change. Suppose your textbook having 200 pages and you are carrying that textbook or notebook, whatever it may be, do there is a change in the number of pages? No. Wherever you go, you will get 200 pages. So like this one, number of particles or number of matter present in that object remains same. So mass remains same everywhere. And so it is only scalar quantity. It do not having effect of direction. So it is not a vector quantity. It is scalar. Only it having the scale. It not depend on direction. You will go up or down, your weight remains same or your mass remains same. Little confusion is that we are using mass as weight and weight as mass. That we are going to make it clear. So is it clear about the mass? Mass is the amount of matter present in the object. It is same everywhere. Wherever you go, it will not change. Again, mass will not be zero. Definitely, if mass is zero, object is not there, so we can raise the question against the existence of that object. So mass should not be zero. These are the all information about the mass. Just move towards the weight. What is weight? Weight is not a mass. But what is weight? Weight is the force with which Earth attracts the object. Higher the mass, higher the attraction, and the weight is more. Less the mass, less the force of attraction, and less the weight. So just see how we are weighing that. Suppose, what is this? Are you getting what is the diagram? This diagram is weighing pans. Suppose this one is a pan A and this one is a pan B. 1 kg mass, kilogram, that is unit. 1 kg object, that is mass, not a weight. It is a mass of object. Here in pan B, not object we have set there. So what will happen now? Within this one, because of the increased mass, Earth will pull that object downward. Before this one, both the pans mass is equal. So equal force, downward force was equal. And so both pans rest at same position without any fluctuation. But when you are going to keep any object of 1 kg in pan A, mass of pan A increases, and due to this gravitational pull also increases because gravitational force is directly proportional to product of masses. So here Earth is same for all these two objects, but here mass of pan A increased, so force increased, and as compared to this one, this force is same, but here because of this 1 kg mass, force increased, so this pan will come down and B pan will go little up. Now what to do? We have to take sugar, whatever may be the one object which are in the form of grain, and start to add grains or that object in little amount. See what will happen now. Suppose that quantity starts to increase. As quantity start to increase, that means mass start to increase. Here is also force starts to increase. And as it is of 1 kg, total mass is 1 kg against the force F1 and force F2. Force F1 is a force on pan A and force F2 is force on pan B, remains equal. And we know that one, how much mass we have kept here? 1 kg. So the sugar or grain is of also 1 kg. So what we have done here? Is it the weight? No, it is the mass. But actually we are using this as a weight. It is not a weight. It is a mass. But because of equal mass of both the pans, force equal, and because of equal gravitational force, both pan A and pan B remains at equal level. Just what you do, if you are going to add little grains or that sugar within pan B, little mass increases. Because of increased mass, gravitational force, that is F2, increases than F1, and this pan starts to come down. As it is coming down, because of this balance, it will go up. Then what to do? We have to remove little mass. As you are removing the mass at one level, both the masses are same and pans rest at stationary equal level. So what we have done here? We have weighed. We are weighing the mass. But what is weight? Weight is not a mass. Weight is a force with which Earth attracts the object. By using the equal mass, we have managed to weigh the object. Actually, we are taking mass by weighing. So, weight is the force with which Earth attracts the object, and mass is the amount of matter present in the object. Number of particles, that kilogram, that is kg, is the mass, but the force with which Earth attracts the object, that is weight, and as it is force, the SI unit of force is Newton, but generally weight is measured in kilogram. Is it wrong or right? Definitely is wrong. Actually, we are getting mass in kilogram by weighing, that is by maintaining the equal force. Yes, this is the gravitational force. So what is weight? Weight is nothing but the force given by the Earth on that object, and that is equal to mass into acceleration. But which acceleration here? Acceleration due to gravity. And so shall we change here into g. And value of g we have. What is value of g? It is mass into 9.8. So if you want to measure your weight, so what to do? Calculate first your mass and multiply it by 9.8. Suppose the object is of 1 kg. So 1 kg is a mass. Then what is the weight of that one? So feed it here. Mass is 1 kg into 9.8. That is equal to again 9.8 or not? That is Newton. And this is the force with which Earth attracts that object towards its center. And so this is Newton is the SI unit, and 9.8 is the weight on the object which is of 1 kg in mass. Then mass remains same everywhere, but weight will not remain same everywhere, because here mass remains same, but weight is totally dependent on value of g, and value of g changes according to surface on the Earth, according to height, according to depth, according to planet, because all the planets having different radius and masses, and because of that one our weight is not same everywhere. Do you know what is the acceleration due to gravity of moon? It is a 1/6 of acceleration of Earth. That means 6 times less than the Earth. Suppose my weight is 60 kg on the Earth. That is Newton. My mass is 60 kg on the Earth, and definitely there is a little force on me, then calculate that one. And if you weigh same thing or same object on the moon, definitely because of 6 times less value of G, we are getting 6 times less weight on G, though mass remains same. So see here, if 1 kg object is weighed on moon, so 1/6 into 9.8 Newton. This much value we are getting. That means 6 times less than the earth we are getting. Again, if we are going to calculate your weight, that is force at the center of earth, definitely value of G is 0. And due to this, weight can be 0 at the center of earth. Now, after this one, we are going to discuss what is the actual difference in between mass and weight. Let's see the difference in between the mass and the weight. Here we are discussing mass, here we are discussing weight. See, this point can be discussed for 3 questions. Number 1, write a note on mass. Second, write a note on weight. And the third question, comparative discussion or comparative study or a difference in between mass and weight. Each question will be asked for 2 marks. So it is totally 3 questions preparation we are doing here. Number 1, difference. What is the definition? First definition will be the difference. Mass is the amount of matter present in the object, as we have discussed earlier. Secondly, weight is the force with which earth attracts the object. Next, SI unit of mass is kilogram. SI unit of weight is Newton, because weight is nothing but the force. Force unit is Newton, so weight unit is also Newton. Mass is a scalar quantity. That means it having only scale. It will not depend on direction. If you go up or down, left or right, mass remains same. Mass will not change. But weight is a vector quantity because it changes according to location. Why? Because we have discussed weight is nothing but the force, and force is equal to mass into acceleration. F is equal to mg. Value of G changes. As you go little higher from the surface of earth, value of G goes on decreasing. So value of G decreases, then multiplication of m and G also decreases. So force decreases, so weight decreases. Oh. So what is here? Weight is a vector quantity. If you are going to come towards your weight increases, though mass remains same. As you go above the surface of earth, definitely your weight will decrease. Fourthly, mass is constant. It will not change. Number of particles remains same everywhere and does not change place to place. But here weight can be changed from place to place. Just we have discussed. Our weight on the moon is 6 times less than our weight is on the earth, because place changes, value of G changes, and because of G, weight changes. Mass cannot be 0. If mass is 0, that means there is no existence of matter. But weight can be 0. Where just we have discussed at the center of earth, wherever value of G is 0, weight is 0. So these are the points. So look this one, mass, these points used to explain, weight, these points to explain, and if you want to explain the difference, then comparative study you have to set forth in front of you. According to this one, mass and weight can be discussed. One example based on this mass and weight. See what is example written on the board. The object mass is 60 kg, then find its weight on the earth and on the moon. That are the 2 sub questions are there. What is given? Mass of object, that is m is equal to 60 kg. Acceleration due to gravity of Earth, that is value of g on the Earth, is 9.8 meter per second square, and acceleration due to gravity, that is value of g on Moon, is equal to 1/6 of acceleration due to gravity on the Earth, 6 times less than the Earth. Then what we have to find? Weight of that object on the Earth, weight of that object on the Moon. See, solution. Weight of that object on the Earth, that is equal to force. Force is equal to mass into acceleration, because we know that one, W is equal to force is equal to mass into acceleration. This is the formula I have used here. Weight on Earth, so acceleration due to gravity on Earth. So value of m is 60, value of g on Earth is 9.8, and multiplication of this is 588. Weight is measured in Newton, and so final answer we are getting 588 Newton is the weight on the Earth. But when this same object is kept on the Moon, then what will happen? See, weight of that object on the Moon is equal to mass of that object into value of g on Moon, that is 60 kg. 1/6 of 9.8, 10 into 9.8, and multiplication is 98 Newton. So it is 6 times less than this weight on the Earth. Do you know, if you want to manage or if you want to walk on the Moon like the Earth, then what you should have to do? Suppose my weight is 100 kg. So definitely my mass is 100 kg. So definitely there is a force of Earth on me, and so I am able to walk like this one. And if you want to walk on the Moon like this, you have to increase your mass by 6 times. So I have to add 500 kg mass on my body, then I will experience such kind of walking. Suppose I am jumping here by exerting little force, 1 feet. By this jump, I am covering the distance of 1 feet. By applying the same force, if you jump on the Moon, then definitely 6 times more distance you will cover. So with the same force, you will cover 6 feet distance. So that is the difference. So it is not easy to walk on the Moon easily, and so I think there is one also walk type, that is moon dance or moon walk. That is, it is not easy to walk on the Moon like Earth, because Earth gravitational force is more, 6 times more. So we are doing here, we having the experience of this one, and on the Moon gravitational force is less. So as gravitational force is less, we are not going to attract toward the Moon so rapidly. So these precautions you have to take. If you want to visit the Moon, you have to increase your weight by 6 times that the existing weight, then only you can get the same feeling of walking on the Moon. So what we discussed within this lecture: concept of Moon, concept of mass, concept of weight, difference in between mass and weight, and the examples depend on mass and weight. Tomorrow's period we are going to discuss the free fall. Thank you.